Section 2 of Chapter 12 is still more vocabulary, but we're going to be talking about arcs and chords and their relationship within the circle. So let's start by describing what a central angle is. It's going to be very key to lots of our theorems. A central angle is an angle that is created by two radii. So in this picture we see several central angles. Angle AOB would be a central angle because it's using the radius as that middle point. So two radius AO and OB create that. Angle BOC and angle COD would also be central angles. Now they're not all necessarily the same because I could use any different points around the circle to create them, so I shouldn't mark them the same. But what I want you to notice is anytime you have O, or whatever the center of the circle is, as the middle letter of your angle, you're looking at a central angle. And one of the theorems I want you to know is that a central angle is equal to its intercepted arc. So we need to talk about the term intercepted arc. Intercepted arc means if this was a mouth or something and angle AOB was extended past those points A and B, whatever is in between point A and B along that circle is called the intercepted arc, because an arc is nothing more than part of the circle, and that central angle cuts off that part. So this theorem is very simple. The central angle equals the intercepted arc. I should say the measure of the central angle equals the measure of the intercepted arc. So if this angle right here is 40 degrees, we know there's 360 degrees all the way around a circle. This arc right here would also be 40 degrees. They're always going to match. So let's look at some more vocabulary for arcs and circles. The word arc means nothing more than part of a circle, but we need to use the right symbols. Just like segment AB has a solid line over it to tell me segment, which is different from line AB, which has an arrow over the top, which is different from ray AB, which has a ray on top. An arc uses a very slight curve to indicate that we're talking about a part of a circle. And we always go in order of the letters. So an arc, we start with two letters, A, B, and that means I'm going from A directly to B. This would be arc AB. Now it's confusing at times because I could go any direction around the circle. Some people say, well, why didn't you go all the way from A to B and you're talking about this big giant part of the circle? Well, there's a reason for that. AB, written with two letters, is what we call a minor arc. And a minor arc always uses two letters. So when you see two letters, you think, okay, I'm going as close as I can from point A to point B, which was this very small section of circle. If I use three letters, BAC, well, that does mean something differently entirely. So BAC, let me get rid of this for you so that's not confusing. Arc BAC says I'm going to start at B, but then the next letter I have to hit is A. So if I go from B to C, that's not arc BAC. That would be minor arc BC. What I'm looking for is arc BAC, which means I have to go from B, the next letter I have to hit is A, and then continue around the circle until I hit C. So arc BAC would be that green arc around the circle that I have right here. So paying attention to the letters is very important. Three letters means you're going to have more than half the circle. It's a major arc. Two letters means you're going to have less than half of the circle, which is two letters. And then a semicircle is exactly half of the circle. And we use three letters for that as well. So let me clean up the circle a little bit so we're not looking at all that. So BAD follows the same idea. It starts at B, I have to hit the next point of A, and then I continue around the circle to D. Well, that's exactly half the circle, which we should know as a measure would be 180 degrees because the whole circle is 360, semi means half, so half the circle is going to be a 180 degree measurement. Know those terms, make sure you understand how we label them using the letters and the symbols. So if you see an M in front, that means I'm looking for the measure of arc BC. Let's use these theorems and these definitions that I've given you. The measure of arc BC, it's 2 letters, so I'm going from point B to point C. Minor arc. The angle coming from the center of that circle, which is why we call it a central angle, is 77, and we know that the central angle equals the measure of the intercepted arc, which is BC, so that's a 77-degree arc. Not to be confused with the length. It's not a 77 centimeter length or inches or anything like that. It's a degree. It's part of the circle. It's 77-degree turn out of the 360 degrees. If I want to find the measure of arc AC, again, 2 letters, which means it is a minor arc. So I'm going from A, and I better not have more than half the circle. So it's just as quick as I can get to C. Well, there's still a central angle there, but I need to use the angle addition postulate. 50 and 77 together is the central angle that's creating that arc, and 50 and 77 together is 127 degrees, so is that minor arc, or the intercepted arc, that was created by that angle. The next one I have is arc DAB. Well, DAB uses 3 letters, so I have to go start at D, the next point I have to hit is A, and I'm going all the way to B. And if I look at that, that's a diameter, D to B. So that means I have exactly half of the circle. So that's going to measure 180 degrees because the whole circle is 360. And now I'm getting kind of messy on my picture, so I'm going to erase all this so I can finish with the last part. And it says, what is the measure of arc ADB? Start at A, next point I have to hit is D, and I can't stop until I get all the way around to B. Now I could do what I did for arc AC, and I could add up all these central angles. I take this angle, plus this angle, plus this angle, and it's going to give me that whole arc. But I'm lazy. What I notice is that I have a 50-degree arc for angle AOB, which means its intercepted arc is 50 degrees. Well, if there's 360 degrees total in the circle, and the only piece that's not being used is 50, that means I have 310 degrees left over for that major arc of ADB. And it is a major arc, so when I'm done I should check. Yeah, it's more than 180 degrees. It's more than half of that circle.